Liking this video will help this channel to grow. So please go ahead and give this video a like. Let me take the time to welcome all my new subscribers to the BBN family. I am so happy that you've joined us and is engaging with the content. Also, please share this with as many people as possible as we continue to build our community. Now, continuing from section 1 of this part 2 lesson, today we'll be exploring how the Pythagoras Theorem applies to the distance formula and looking at the coordinates on the coordinate grid. As always, I have included some independent practice questions and mark scheme which can be found in the description of the video. Now, let's look at how we can apply the Pythagoras Theorem to coordinates. We can use Pythagoras' theorem to find the distance between 2 points on a coordinate grid using the distance formula. What is the distance formula? Now, the distance formula calculates the distance d between two coordinates. And of course, we know that coordinates come in an ordered pair where we've got an x value and a y value. So the first point we would call x1, y1, and the second point x2, y2, and these are located on an xy coordinate plane. Now, let's say, for example, we're given 2 points A and B. A is 3, 5 and B is 8, 6. So we would label them. So 3 would be our x1, 5 would be our y1, 8 would be our x2, and 6 would be our y2. Now, let's have a look at what the distance formulas say. So the distance formula is given as d for distance. If we want to find the distance between 2 points, it's equal to the square root of x2 take away x1 squared plus y2 take away y1 squared. What do you notice? You should have now watched part 1 of this lesson. So if you did, you would have recognized that this actually is the Pythagoras theorem, but it is written in terms of coordinates, in terms of just the actual number for the formula. Beautiful. So now we're going to look a little bit closer as how we could rearrange the Pythagoras theorem by making the d the subject. Now, the Pythagoras theorem here states that a squared plus b squared is equal to c squared. Now, c would have been considered the distance that we want to find. C is actually the hypotenuse, which would come a little bit more clearer when I put this up and we explore it diagrammatically. Now, what if I wanted to make the hypotenuse, which is c, the subject of the formula? I can see here that at the moment I'm given c squared, but I want c on its own. So what we would need to do is to do the opposite of squaring both sides, which is actually finding the square root. So let's put this down. So I'm just going to rewrite a squared plus b squared is equal to c squared. So to get c on its own, I need to do the square root of both sides. So square root of c is c, of c squared is c, so c is therefore equal to a squared plus b squared. You can see here that this is actually the distance formula. Now, the only difference here is that a and b would represent the actual distance between the two pairs of coordinate. So once we substitute them into the distance formula, we would now have, instead of x and y, we would have actual numbers which will represent a and b. So again, distance formula is equal to the square root. You can see this here, square root. So x2 take away x1 would give us an actual value, that would represent our a in the formula for Pythagoras theorem. And y2 take away y1 would give us the actual value for b, which we would then square. Okay, so let's have a look now. It's going to be so much more clearer when we get into our examples. But first of all, let's talk about how do we use the distance formula. Now, to calculate using the distance formula, we follow the steps below. Step 1, we must first of all identify the 2 points that we're given. They will come in terms of letters A, B, C, whatever the letters are. Identify the 2 points that we're given. We will label them x1, y1 and x2, y2. That's the first step. Step 2 is to substitute the values into the distance formula. So it's very important to know your distance formula. But when I put the diagram up, I'll also show you how you could still use the distance formula, but use it in the form just of the straight Pythagoras theorem. And then we will find the difference between them. So actually here where we got x2 minus x1, we'll actually subtract them to get a final value. Step 3, we solve the equation using Pythagoras theorem. Beautiful. So let's have a look at our first example, and then we'll put this all into perspective. So we're asked here to work out the distance between points A and B on the coordinate grid shown below. So we observe first of all that A is the coordinate. So remember, we read our x value on the Cartesian plane first of all, followed by y. So the coordinate of A is 3 across for x and 2. So let's just write that down. A is equal to 3, 2. And B is equal to, we go across, minus 2, minus 1. So B is minus 2 minus 1. So we identify, we've done our first step, we've identified A and B. Now step 2 told us to, we need to first now label the coordinates. So the first pair would be x1, y1. So 3 is x1 and 2 is y1. In the second pair for B, we would now have minus 2 to be x2 and minus 1 to be y2. Beautiful. Now, what we need to do is to write out our distance formula and then substitute these values into the formula and then calculate and solve for the distance. So D here is equal to, let's copy the formula, I've just put it here as you're getting used to this. It's equal to the square root of x2. So I'm going to write it all out first of all. x2 minus x1 squared plus y2 minus y1 squared. Do not forget your square. Now we're going to substitute from the values we've labeled here into the formula. So D would be equal to x2. Let's find x2. x2 is minus 2. So it's a square root of minus 2 for x2. Take away, what are we subtracting? So this is our takeaway sign, x1, which is 3. Close our bracket and square. Plus y2 is minus 1. You can see that here. Take away, that minus is in our formula, y1 is 2. So we're subtracting 2 and we need to also square that. Now that we've done our substitution, all we need to do is to work this out. Truth be told, we could just put this all in our calculator by pressing square root and then put everything that as we've got it on the screen and then press equal. However, let's just work this out. What if it is a non-calculated paper? So minus 2 minus 3 is minus 5. So we're doing minus 5 squared plus minus 1 minus 2 is minus 3. So we're doing minus 3 squared. So put back our D here. So minus 5 times minus 5 is positive 25. So that's 25 plus minus 3 times minus 3 is positive 9. So essentially we are adding 25 plus 9 and we need to find the square root of that. So we are doing square root of 34. So 25 plus 9, 34. Let's just put that in our calculator now. Square root of 34, we're going to give our answer to one decimal place. That is 5.8 units. Beautiful. So the distance, I'm just going to show you now how this makes more sense as you can visualize the Pythagoras theorem here. So let's have a look. So if I join the 2 points together here and I go across and complete my triangle, I can see now I've got a right angle triangle. So basically what I was finding all along is the hypotenuse of the triangle. The hypotenuse is the distance from A to B. Now let's have a look and see how did we get this 25 and this 9. If I count the units on the graph, 1, 2, 3 down, and 1, 2, 3, 4, 5 across, gets me 5. So 5 times 5 gets me this 25 here, and 3 squared gets me 9 here. So this means if you do not remember the distance formula from your head, you could just on the coordinate plane complete the triangle and then just use Pythagoras theorem. You could have just used a squared plus b squared equals c squared as well. Now there are times on exams where based on the complexity of the question, you would have to use the distance formula and solve for the unknown, particularly if you didn't get a coordinate grid and you had to visualize the coordinates on your own. Beautiful. So now we're going to do another example. Now that you see the rhythm of this and how the two links together and that the distance formula is actually the Pythagoras theorem, now we'll be able to go a little bit faster now. So I've got here another coordinate plane. This time the grid isn't there at all. We're told that A is the point with coordinates 2, 9. B is the point with coordinates 10, 1. We're asked to calculate the length of the line segment AB. So again, we're just going to write the coordinates. I'm just going to visualize for you first of all the triangle. So if I go across and go down, I can see here that this is my right angle and A to B again is my hypotenuse. So I can just do a squared plus b squared equals c squared. However, I would still have to subtract my coordinates, my x coordinates to get the distance across, and I have to subtract my y coordinates to get the distance vertically. So let's go ahead and write A to B 2, 9 and B to B 10, 1. We're going to use the distance formula because I want you to practice this. So D is equal to the square root of x2 take away x1 squared, don't forget your square, plus y2 take away y1 squared. Beautiful. So let's go label our coordinates now. x1, y1, x2, y2. We're going to now substitute into our formula. So x2 is given, so x2 is 10, so we're doing 10 take away x1, which is 2, and we need to remember to square that, plus we're doing y2 is given as 1 take away, and y1 is 9, and we also need to square that. So let's go and do the math. So 10 take away 2 is 8. Essentially, we are doing 8 squared for the first, plus 1 take away 9 is minus 8. We're squaring minus 8. Let's go. So we know 8 times 8 gives us 64. Also, negative 8 times negative 8 also gives us positive 64. Now what we need to do is to add them together and then find the square root. So 64 add 64 is 128. So we're just going to put that in our calculator. What is the square root of 128? So square root of 128 That's equal to 11.3 units. Let's just say units since it's a Cartesian plane. Beautiful. Now, if you look here, I could have just done the x coordinates together. 10 take away 2 give me 8, so that's 8 across. And then I'm doing 1 take away 9, which is minus 8. However, we cannot have negative units, so it will still be 8. And then I would just need to do a squared plus b squared equals c squared. So it still would be 8 squared plus 8 squared, which is equal to c squared. So again, you can see it takes us right back to here in the distance formula, 64 at 64, if we should work that out. So two alternatives for you to use, and you would use them appropriately based on the fact that if you're given a diagram and you can visualize it. However, if they ask you to use the distance formula, you must use the distance formula. So we're going to do our final question here, and then it will be time for our key takeaways. Beautiful. So here we're asked to calculate the perimeter of triangle ABC. So if we notice here on the diagram, we're already given one side of the triangle to be 7.1 units. Therefore, in order for us to find the perimeter, remember the prefix peri means around and meter means to measure. So essentially we are asked to find the distance around the triangle. However, we notice we do not know the distance from A to B, and also we do not know the distance from B to C. So we must use our distance formula to calculate those two missing bits. Then we can add all the sides together. Amazing. So let's go for AB first. So A is equal to minus 3 minus 1, and B is equal to minus 1 and positive 5. Let's go ahead, label our coordinates. So x1, y1, x2, y2. So substituting our distance formula. So let's write that here. D is equal to the square root of x2 take away x1 squared plus y2 take away y1 squared. Now let's substitute. So x2 is equal to minus 1. So we're doing the square root of minus 1 take away x1, which is minus 3. So notice here we got two negatives, so the minus sign that comes in the formula is different from the negative 3 that is in the question. Must take note of that. Plus y2 is given to be positive 5. Take away y1, which is minus 1. Again, make sure you put those two minus there. Now it's time to calculate, or we could just put this all in our calculator, but taking opportunity here just to remind you how to navigate adding negative numbers. Now remember, 2 negative will give us a positive, so I'm just going to put that plus here. Essentially, I'm doing minus 1 plus 3, which is the same as 3 take away 1, and that's equal to 2. So I'm doing the square root of 2 squared plus 2 negatives again give me a positive, so I'm doing 5 plus 1, which is equal to 6. So I'm squaring 6. Working it all out now, I get 2 squared is 4 plus 6 squared is 36. So 4 plus 36 is 40. So I'm doing the square root of 40, again putting in my calculator. For those students doing GCSEs, some questions could have asked you to leave your answer as a simplified surd. If they ask you for a surd, you would see this on a non-calculator paper. Now, the answer to square root 40 is 6.3. So we found the side AB, which is 6.3. Finally, we need to find the side BC. So let's go. B is equal to minus 1, 5, that's the coordinate, and C is equal to 4 minus 2. Again, label x1, y1, x2, y2. We're going to substitute that into our formula. So D is equal to The square root, let's write that here, D is equal to the square root of x2 take away x1 squared plus y2 take away y1 squared. Okay, so let's go. X2 is equal to 4, so square root of 4 take away x1, which is minus 1, we need to square that, plus y2 is minus 2 take away y1 is 5, and we need to square that. So let's simplify. We could just put this all in our calculator. So let's go. Let's put that in our calculator straight away. So give me 1 second to bring my calculator back. Alright guys, let me do it without the calculator because my calculator is kind of acting up. Let me try one more time to see what's going on. Okay, so adding these together, I get 4 plus 1 is 5, so that's 5 squared, so it's a square root of 5 squared, and then minus 2 minus 5 is minus 7, so I'm doing minus 7 squared. So 5 squared is 25, so that's a square root of 25 plus 7, minus 7 times minus 7 is 49. So I need to do 25 plus 49 and then put that all in my square root for my calculator. Calculator still giving me a problem here, guys. Just bear with me. Okay, so let me just add these manually. So 9 plus 5 is 14. And then I need to bring 1. So 4 plus 2 is 6 plus 1, 7. So essentially, I'm doing the square root of 74. So the square root of 74 is equal to 8.6. Very good. So I'm going to put that on my diagram now. And then finally, I can now find the perimeter since I have all three sides. So the perimeter is equal to 7.1 plus 6.3 plus 8.6. Beautiful. Put that quickly in my calculator now. So 7.1 plus 6.3 plus 8.6, and that's equal to 22 units. Beautiful. So you see how we can apply our Pythagoras to finding the distance between two lines, and also it can also be applied to other questions as we have just interwoven that into the perimeter of a triangle. Absolutely brilliant. So we are at that point where we do our key takeaways. Beautiful. So we've spoken about the fact that we can apply the Pythagoras theorem to find the distance between 2 points on the coordinate grid using the distance formula. We talked about the fact that if we've got our coordinates, we label them x1, y1, x2, y2, and then what we need to do is to substitute them into our formula and solve. We could also see that once we are good at rearranging formula, we could rearrange the Pythagoras theorem to find any one of the variables involved. Brilliant. Now, I hope that you notice how all of our concepts in mathematics interrelate to each other. So it therefore means that we should always go after understanding every concept that our teacher teaches us, because at somewhere in our learning process we will need to apply concepts we have learned previously. That's the beauty about math. You can use other concepts and interweave them into other ones. Beautiful. Now, by now, you should have subscribed to the channel. You should have shared to at least 10 friends. You should have also made sure that you go onto our TikTok page and interact with the exam questions. Beautiful. Guys, I'm so happy that you are a part of this community. And let's continue to comment and like those videos so that we can propel the algorithm to share this beautiful content with other viewers as well. Until my next upload, guys, thank you so much for watching.